Hi, I'm Derek with Bolton Pro. Today we're going to talk about amplifier cable. We'll go over the different types of cable available, the difference between 75 and 50 ohm cable, how to calculate your max cable length, and some installation tips. We're joined here by our friend Dan, a certified installer, and he's going to walk us through everything.
Well, there are many types of cables on the market today, but there are primarily three types of cables that you'll encounter when installing a signal amplifier: RG6, RG11, and Wilson 400. The main differences between these cables are cable loss and the connectors they use. RG6 cable is what you'll find installed in many homes as the standard for cable or satellite TV. RG6 has a cable loss of 5.5 dB at 700 MHz and 9.5 dB at 2100 MHz per 100 feet. This type of cable uses F connectors and is a 75 ohm cable. RG6 is recommended for homes or smaller installs. We do not recommend RG6 for commercial jobs or for lengths of over 50 feet due to excessive signal loss. RG11 cable looks like this and has a loss of 4.5 dB at 700 MHz and 6.5 dB for 2100 MHz per 100 feet. RG11 also uses F connectors and is a 75 ohm cable. We recommend the RG11 for residential or smaller commercial applications, as it has less cable loss than the RG6. Wilson 400 cable looks like this. You can see that it is much thicker and more durable than the other two cables. Wilson 400 cable has a loss of 3.5 dB at 700 MHz and 6 dB at 2100 MHz per 100 feet. This type of cable uses end connectors and is a 50 ohm cable. The Wilson 400 cable is ideal for commercial applications. We also recommend this cable for when you are splitting into multiple broadcast antennas. Also, you can use this cable for when your incoming signal is okay to poor. There are more commercial grade cables available in 50 ohm like LMR 600 cable and plenum cable. So what's the difference between 50 and 75 ohm cable? 75 ohm cable is CEDIA industry standard, while 50 ohm cable is commercial industry standard. 50 ohm cable has slightly less cable loss per 100 feet of cable. You can determine your max cable length by taking your incoming signal reading, then subtracting any losses from cable, splitters, and any other accessories. Add in how much your amplifier boosts the signal as well as any gain from antennas, and you've got your final number. This number shows you how much signal you'll be providing throughout the building. In general, it is ideal for the signal coming into the amplifier to be 70 dB or better. Also consider the amplifier you're installing and what type of connectors it has. You'll need to either run the cable with the corresponding connectors or use adapters to connect your cable to the amplifier. We suggest you keep your cable runs under 100 feet from the amplifier to the antenna if possible. If you do have to go further than that, make sure you are using Wilson 400 cable to minimize cable loss. As an insurance policy, be sure to install a lightning surge protector just in case lightning strikes your donor antenna. These are very low loss, so you don't have to worry about them affecting the signal much, and they come with a replaceable gas discharge element. In the case of a lightning strike, the electricity travels down the cable to the lightning surge protector and is discharged at that point, protecting all of your downstream equipment. You simply need to replace the discharge element and you're back up and running.